Welcome. All right, back to space. That's great. So I think one of the interesting things that we were talking about is a lot of the technology that Lockheed has built actually like enables a lot of the consumer technologies that we hear about with geolocation and stuff like that. So like talk a bit about kind of the breadth of Lockheed's business and especially the commercial kind of space side of the business.
Yeah, so in our space business, we're building satellites for military intelligence, commercial applications, so commercial communications, sort of providing connectivity across the world. In addition to that, in my business, which is the coolest job at Lockheed Martin, we build spacecraft that explore our solar system, both robotically, and we're building Orion, which is a deep space spacecraft that's going to take humans to the moon, onto Mars, and potentially beyond.
Nice, yeah. Orion, so you've made significant progress for Orion even just this year. I think in the summer you had a key milestone, which was, can you want to explain a bit about that?
Sure. In July, we had a milestone that was a testing of the launch abort system for Orion. So the launch abort system will sit on top of the capsule, and when the vehicle is on the pad to launch, and as well as when it's accelerating during launch, we could take, if there's an anomaly that goes on, some sort of accident that occurs, the launch abort system kicks in and it pulls the crew module safely away from the rocket, and then it will jettison itself, and the capsule will deploy its parachutes, and then deploy or just softly land in the ocean there to bring astronauts out of harm's way.
Right.
So it's a really, really important system for crew safety. We hope to never use it,
but
we've done a pad abort test, and we just did in July the ascent abort test. So we just proved out the system, and it's now ready to fly. So we're really excited about that.
That's great.
Yeah.
So ready to fly. When you say that, I don't know that everybody understands necessarily like space timelines for how does that mean that you've got people going in it tomorrow and they're going to go up?
Yeah. So. You know, I think Bob Smith talked earlier with you. I think he talked about safety, right? And safety is our #1 priority, especially when we're flying crew. And so there's a lot of testing and validation that we do to convince ourselves and our customers that we're ready to fly and that it's safe for crew to fly. So we've done the launch abort system test, which is a emergency, exit, if you will, and next, we're going to be flying Artemis 1, which is an uncrewed mission. It's about a month-long mission where we'll be orbiting around the moon. And it's really to test out all of the systems and make sure that they can withstand the radiation environment, and that when we come back into re-entry, that the heat shield is sufficient enough to protect the astronauts inside the capsule from the extreme heat that they'll experience as they enter the Earth's atmosphere, that the parachutes deploy correctly, and that we can get the crew out when they return to Earth. So that mission is in late next year. The crew module for that has been completed. Actually, we had the privilege of having the Vice President down at Kennedy Space Center for an Apollo 50th celebration, and he declared Artemis 1 crew module complete. And that is now stacked on top of a service module, which actually comes from the European Space Agency, so it's got an international flavor to it as well. And it will be going to NASA's Plumbrook Station, which is just a huge thermal vacuum chamber where we actually test the capsule in the environments that it'll see in space. So we're excited to go through the TVAC, and then it'll come back and get put on top of the Space Launch System rocket, and off it'll go.
Nice. So that's, you mentioned the Artemis, right? That's Artemis 1. So this is the Artemis program that NASA is running to go back to the moon, to bring, how do they put it? The first American
female.
Woman.
And the next man to the surface of the moon by 2024.
That's right, by 2024. So that's the key thing. So that date, I hear a lot of skepticism about that date when I talk to people and when I see people talking about it kind of in social communities and stuff. So how do you feel about that? You know, NASA Administrator Jim Bridenstine repeats it very frequently. How do you feel about that date? What's your confidence in that date?
You know, I think it's really exciting to have a deadline to get humans back to the moon and then beyond, right? And it's not just going to the moon and then we're done. It's going to the moon and being there in a sustainable way, and really using what it takes to get to the moon and what it means to be in deep space, so that it helps us to bring humans further into our solar system, onto Mars, because they have to be self-sufficient. There's a lot of autonomy that's required, AI that would be required in our systems, because they can't just phone home and say, Houston, we have a problem, when you have a delay in terms of the latency and comms. So I think 2024 is extremely doable, but there's some conditions for that. I think one, we need funding to be able to support that, and two, we need to reuse what's already been developed. And at Lockheed Martin, we're really proud of the crew life support system, as well as the crew equipment, displays, controls that we've built for Orion. And we think all of that is transferable onto the lander that will be required to take humans to the surface of the moon. So what people may not understand is that Orion's going to fly to the Gateway, which is an orbiting platform around the moon. The astronauts will get off of Orion, and they'll go onto a lander, and then they'll get into the lander, and they'll take the lander to the surface of the moon.
So it's not a direct flight. They have a connection.
It's not a direct flight, and neither was Apollo.
Right.
They had a LEM, lunar exploration module, that they used to get down to the surface of the moon. And then that ascent element of the lander will go back to the Gateway with the astronauts, and they'll get back in their Orion and come home safely. But when you take your astronauts out of an Orion and you put them into the ascent module of the lander, wouldn't it be great if it was the same systems and you could train them once and they knew how to use that? So think about when you rent a car, and let's say it's a model that you're not used to, how long does it take you to figure out, like, how do I turn the windshield wipers on, or where's the light controls? You don't want astronauts to be worrying about things like that.
Yeah, that's great.
So we call that Orion Inside.
Oh.
We're really excited about using those systems into other elements in this architecture.
And that gives you cost benefits too.
Obviously, yeah. You've already done the development. You've qualified that. So it's a lot of testing, as I said, that we have to do to convince ourselves that it's safe for humans. So if you've already done that, why would you spend the resources to do it again?
Sure, that makes sense. And then it also that leads into kind of the other recent news for Orion is NASA has placed a large order for 6 to 12, I believe it is, right? 6 minimum, up to 12 Orion capsules through 2030?
Yeah, so just last week they announced that they awarded Lockheed Martin the Orion production contract. Yes. So you're right, it's for a minimum of 6 crew modules that we would be developing, and they have an opportunity to order up to 12 of them. And so it's for Artemis mission 3, 4, and 5 was the first order. And Artemis 3 is critical because that is the crew module for Orion that's going to take the first female and the next man that'll up to the Gateway, and that'll be the landing mission in Artemis 3, so in 2024. So really excited about that. Yeah. And the team's been working really hard to look for ways to really reduce the cost as we get into production. One way that we're doing that is through reuse. So what people may not know is that quite a bit of Orion is reusable. And we've been qualifying the equipment for multiple uses to make sure that that equipment can be used over multiple times. And so there'll be reuse. There's been a lot we've done in automation. Augmented reality has been a really cool thing and really has had a big bang in terms of our productivity for our technicians on the floor that are building Orion. We actually give them goggles that they can put on with augmented reality. They can see their work instructions through those goggles, and they can actually see the placements of where they would put fasteners and other things on the spacecraft. So tasks that used to take 2 or 3 technicians 2 or 3 days to complete, we can do it with 1 technician in about 2 hours. And so when you have that kind of technology, are you developing that all in-house, or are you working with partners, or how does that, like the AR stuff specifically? Yeah, so we're using a lot of commercial off-the-shelf AR technology, but one of the things that we do with our spacecraft is every one of our spacecrafts we build a digital twin of. So think of that as we build our spacecraft digitally before we ever bend any metal. And by having that digital twin of the spacecraft, we can use it in the design process to make sure that we have the right clearances for equipment and things. We can use it during manufacturing, as I just highlighted, with work instructions, as well as where do you put fasteners and technology. But then we can use it during the mission. We can actually run the mission on our digital twin here on Earth. So if there are issues with the spacecraft, we can see where and help to debug from here on Earth. Right. And eventually that digital twin could be on the spacecraft itself. So when astronauts are at Mars, hundreds of thousands of miles away from here, they can use a digital assistant and interrogate this digital twin to help them make decisions on where they look first for any problems that they may be having,
So
or
maybe
how to
like,
use a backup system that maybe they weren't as aware of.
is that like if they wouldn't have to do EVA, for instance, without being informed first through something like that?
Yeah,
or-
yeah. And if they did have to make a repair, they could use this digital environment to train on how to make that repair before they actually test the actual hardware or touch the actual hardware.
So then, like, that seems like a great opportunity where like you can lean on partners who are more expert in that field to come in and help, right?
Yeah.
As providers, technology providers. Where else does Lockheed look to kind of industry, to startups, to younger companies to support the work that they're doing?
Yeah, we love, I'm excited to actually be here because there's so many great startup companies, and many of which are in space these
Yes.
days. So Lockheed Martin has a group called Lockheed Martin Ventures. Chris Moran leads that for our organization. And we make investments in startup companies and are really looking to try to help accelerate some of these startup companies, because they've got key technologies that we need that maybe are used here on Earth, but we want to apply them into a space environment as well. So in the last 2 years, we've doubled the investment that we're making in companies. So our budget for that's grown to over $200 million now. We've got investment in small satellite companies and small launch companies, and we're continuing to work in a mentoring way as well as in a financial way with these companies. So
Great. And is that also like an acquisition funnel for Lockheed?
it could be,
Yeah.
absolutely, it could be. I will mention on Orion that for every dollar that's spent on Orion, 60% of it goes to supply base. So we do have a huge supply base, and of that 60%, 30% of that is to small businesses. So we've got businesses across the United States, and almost every state in the US is supporting us in that. And those small businesses, there's just one story after another of great ways where by companies getting into space and aerospace industry, they've totally reinvented themselves as a company.
And it has benefits to other aspects of their business.
Of course,
yeah.
and then it helps their business and helps them to grow over time.
Yeah, I mean, this is an interesting, because again, I asked Bob about this too, but there is a perception that this money is perhaps better spent elsewhere, right? So you don't see the ecosystem effects, I think, a lot of the time, but like, Lockheed must get that kind of criticism, right? Like, you're getting these very valuable contracts that are government contracts,
Right.
so it's government money going into space, and people are saying, well, why don't you just spend that here at home, right? So on Earth.
Yeah, but the thing is for every dollar you spend in space, the benefit is exponentially bigger on what it means here on Earth. The technologies that we're getting out of space, like how many people here had to use a GPS to find the location of this facility? And that came out of the government investing in technology that's there. I lived in Florida for years. I had an ionization on my system on my pool. I didn't use chlorine, and that came out of a space shuttle system of how they purify water on station in the vehicle. So we benefit from that technology. And then the other piece is space is really cool. It inspires the next generation.
Yeah.
And I'm so excited that we're excited about talking about space and sending humans back to space, because we need more folks to be excited about science and technology and engineering and math. And the more we can inspire that next generation, it'll benefit all of us.
Yeah, I mean, that's an interesting point you bring up, because I think that I've talked to a lot of people who have said, it's again, there's an excitement that hasn't been there necessarily since the shuttle program,
Yeah.
right? And also, I was talking to an entrepreneur that we have in our battlefield, and he was saying, I can hear NASA changing on the phone. Like, I can just hear the change happening about how they approach, because of the entrance of private or new private companies, and because of kind of the enthusiasm around it. Have you noticed that? What has it been like to change through this, especially as you see competitors emerge, like a SpaceX, right?
Yeah.
Competitors and partners sometimes, right?
Yeah. Yeah, absolutely. I mean, again, the excitement, we're on the brink of a new space age. We've have more than 900, 1,000 startups that are coming in this area. You do have folks like SpaceX or Blue Origin that are getting people excited about it. And to your point, it's a discretionary expense. So if you can get the public excited about explorations and sending humans into the solar system, and all of it is to benefit what we do here on Earth.
Right.
the more we can learn about our solar system, the more it can benefit us in understanding how did Earth, come to be, where is it going in the future, what do we need to be doing to protect this planet, because we owe that to the future generations.
Yeah, I mean, that, I think, gets at, again, the problem of, like, there's still the what's in it for me attitude, and not in such a selfish way, but even for the startup, the small business crowd, it's like, what does a mature space economy look like? And then where do I fit in? Where do I benefit from that? So what do you think about that? Like,
well, I think if you look at space, right, there is no infrastructure in place in space right now, other than commercial launch that's there. But how are we going to transport people? Once we get them there, what are they going to do? There's very limited bandwidth in terms of communication. So all of that, everything we have here on Earth, and as technology continues to explode and make our lives better, we need to take all of that into space. So I think there's a lot of opportunity to take the same kind of infrastructure that we have here and move that more into space. And that's where I think companies can continue to grow and expand, and how do they take those technologies and transfer it there. I think the thing about space is it's somewhat unforgiving, right? Electronics, things have to be hardened and reliable and self-healing, and but once we can get past that, and we have for a lot of technologies, the sky's the limit.
right. But then what's the economic engine for that, right? Because it seems like it's, again, a lot of, like, upfront cost, upfront risk for long-term rewards. And our audience, our VC friends don't necessarily have those timelines in mind, right? So how do you drive upside now in order to build a kind of sustainable infrastructure?
Yeah, I think you have to start small. But I think the government's going to play a pretty big role in helping with some of that infrastructure. They already have, right? NASA has International Space Station. They've been offering it to commercial industry now for many years to bring technologies out there. They're giving them free transportation there. They're letting them, drug manufacturers are looking at new drugs. There's fiber optics that's being built in space. There's manufacturing in space. So there's a lot of new technologies, and NASA's providing that infrastructure to allow startup companies to try new technologies and see what it takes to actually perform in space. And I think you'll see that continue.
And what about more near term? Like, you work a lot at Lockheed in robotics and robotic exploration. So can you talk just a bit about those programs? I don't know if you want to, we do have some presentation. We should probably bring it up, if we can bring up the slideshow, because it's super cool.
Yeah.
So I just want to look at it before we go.
So we've been exploring our solar system for more than 4 decades.
Yeah.
And probably longer than some people in this room have been alive. And so we've got 8 spacecraft that we operate for NASA right now out of our facilities. And I just brought a couple of cool images to share with you guys.
They're up there.
Oh, okay, perfect. So the first one here this is an asteroid, Bennu. So this is a near-Earth asteroid. It actually has a very slim chance of actually impacting Earth one day. But we have a spacecraft called OSIRIS-REx that is orbiting around Bennu right now, and it's made this image from its instruments that are on board. And we continue to learn things that we had no idea about. So we found out that Bennu is much rockier than we ever expected, and we're actually next summer going to tag this asteroid and bring back a sample to Earth. And the reason we want to know more about the asteroid is it helps us to understand how the solar system was formed, and even because it's a near-Earth asteroid, how Earth was formed, and that will help us understand our own planet better. But this asteroid is really rough, and so we've been trying to identify where we're going to tag it.
Right.
And on top of that, it's actually spitting particles at us, so we have to protect the spacecraft from those particles as well. So tremendous amount of stuff there. So again, next summer we'll be tagging that, and that will come back to Earth, so pretty exciting. These are just some more images of that Bennu and how rocky it is.
And does this have like a potential commercial applications? Like, do you think about that when you're doing this stuff?
So there are companies out there that are talking about asteroid mining, right? Yeah. There's a lot of minerals and precious metals that are in these asteroids, and if you could mine those asteroids and collect those metals, you could actually do in-space manufacturing. And one of the biggest costs to space right now is getting things off of Earth. If you could actually do things in space outside of the Earth's gravity well, it's a lot cheaper to move that, and the costs go down incredibly. let's see what else. This is a picture of InSight on Mars. So that's an actual spacecraft that landed on Mars back in November, right after Thanksgiving. And InSight is really studying the interior of rocky planets. So it's not so much about Mars, but using Mars to help us understand more about planets like Earth and rocky planets. So it's got a seismometer on it, which is in the upper right-hand corner. And NASA just released yesterday, if you go out to their website, some new sounds that are coming off of Mars. So there's the sound of the wind, there's Mars quakes, which we're measuring on the seismometer, as well as you can actually hear it when the arm moves around. There's also a thermal probe on it that's going to dig deeper into the Mars to understand more about the core of Mars. So a lot of great science there. And then this is a picture of Jupiter. So we have a spacecraft we're operating for NASA that's called Juno. It entered Jupiter's orbit on 3 years ago in July of 2016. And that black spot on top of Jupiter is actually, we caught an image where we were seeing the shadow of one of Jupiter's moons shadowing down on the surface of Jupiter. So we are literally rewriting the science books around Jupiter with Juno. We are learning more about it than we ever thought before. We thought it had a really tight core with a lot of gas around it. We're finding that the core extends almost 50% of its radius, and it's very squishy. It's not really a hard core, and it's not uniform at all. So stay tuned. We're learning a lot about the solar system, and we'll learn a lot about what that means for Earth as well.
That's great. All right, thanks very much, Lisa.
Yeah, thank you.